This lesson is on linear relations. What do you think linear means? Hopefully you see the word line in there. So this just refers to relations that form a line. Okay? And what does that mean? Well, if we were graphing it, it would mean that it's going to form some sort of a line like this. Okay? If we see it in a table like this, we should be able to see a constant rate. Remember I told you if there was a straight line, it had a constant rate of change. It was always the same. So if this is going up by 1 every time, this must be going up by the same amount every time. And if that's the case, then I should have 18 here, 24, and 30. Okay? This is going up 3 for every 1 that it goes up there. Right? That tells you that it's linear. We're going to say it's constant change. All right? Let's see if this next one is linear. Okay, well, I'm missing some values here, so I can't make that similar prediction. So what do you think's happened to get me from there to there that would also work to get me from there to there? Okay. Well, a quick glance says I think I should multiply by 2 and then add 4. If I multiply by 2 and add 4, it works for each of these. Okay, so if I multiply by 2, add 4, this would be 6. And now you can see that I am going up 2 every time. Okay, don't worry if you had a little trouble finding those values. I'm more interested in, can you see how this is linear? Because there is constant change, both for this one and for this one. Okay, in fact, it'll also be constant change here. All right, let's try to figure out what are we doing to get from there to there and from there to there. I think the rule here is multiply by -3 and then add, what would you add? Add 13. Okay, so yeah, that's going to do it. So multiply by -3, add 13. Multiply by -3, add 13. And you can see now that I'm going up by 3 every time, or sorry, down by 3 every time. Okay, so that's what a linear relationship is. Here's another example of a linear relationship. You can see here, straight line, constant change. Okay, this graph is representing this table. Hopefully it makes sense that you can see I'm going up by 75 cents for every extra topping. Okay, do you think I should connect the dots? I don't think I can have half a topping. I know I can put topping on half the pizza, but I can't have half a topping. So we're not going to connect those dots. Okay, what patterns do you see? I see 75 cents per topping. I see a constant rate of change. I see $12 for a pizza plus the number of toppings. So let's write a rule. Okay, a rule would say, what variable should I use? How about if I write cost and number of toppings? Okay, so the cost, let's write it in function notation, would be $12 plus 75 cents for every topping. Okay? Hope that makes sense. How are the patterns shown in the table on the graph? Well, it just shows up that it's going 75 cents every time. All right. We're getting into the nitty-gritty here. The linear relation is a constant change. So as the independent variable changes, the dependent variable changes, and they're going to be constant. That will give you an equation of a line. This is the equation of a linear relation. So equation of a line. We're going to spend the entire next unit on this. This is an introduction to it. Okay, what is y? Dependent, x independent. Nothing new there. B is the initial amount. That's what I start with. And m is my rate of change. Okay? By the way, rate of change is, you can write this in a couple of different ways. This is the change in y over the change in x. Okay, and to get the change in y, you're going to subtract the two y values divided by the two x values. Okay, those are formulas we're going to use. I'll use them and you'll see what they mean very shortly. The rate of change is constant or stays the same for a linear relationship. That's why it will form a straight line. So determine the rate of change in the pizza example. Okay, this is what we wrote, $12 plus 0.75 N. I'm just going to switch these two around and write it in this form, 0.75 N plus 12. And then I want you to compare it to the equation of a line. Okay, so I'm just using y instead of c. I'm using x instead of n. All right, what is the rate of change? The rate of change was this value in front of the x, the m value. So in this case, our rate of change would be 0.75. Now 0.75 what? Dollars per topping. You always have to have a unit. That's my rate of change. That's how fast the cost of the pizza will change. All right? What does each part of the formula determining the cost of pizza describe? Well, here is the other part, B. B is 12. What does that mean? That means the initial, the starting point. The initial value is $12. So this means if I have no toppings, I get $12 for the price of the pizza. Okay. Let's try some. Which table of values represents a linear relation? So the other ones I told you they were linear. This time I want you to decide if they're linear. How do I know they will be linear? It will be a constant or a consistent rate of change. So the change in y will be divided by the change of x will be consistent. So let's see. Here we're going up 5 every time. Okay, it's going up 5. What are we going up by here? Plus 9, plus 9. And you can see that the rate of change is the same no matter which two values I take. Our rate of change would be the change in y, so this is y, over the change in x. Okay? Now let's look at the second one. Here we're going up by 5. What are we going up by here? 75? And this time, 225. Well, you can stop right there. You can see the rate of change is not consistent. Okay, 75 divided by 5 is not the same as 225 divided by 5. So this is not linear. Okay, when we graph that, I mean, you could do this. You could graph it, and you could see that it would be making some sort of a curve here like this, getting faster and faster. All right, next one. Trying to determine if this word problem is linear. My advice to you is translate these words into some numbers. Okay, so I'm going to put x and y. What is x? A new car is purchased for $24,000 every year. The value of the car decreases by 15%. So when you buy the car, it's worth $24,000. After 1 year, what will be the price of the car? Okay, well, it's decreasing by 15%. So if you have the value of a car and you take away 15%, does it make sense that 85% is left? Okay, so I'm going to go 85% of 24,000. All right, and 85% means 85 divided by 100, so 0.85. Of means multiply. Okay, so that equals 20,400. So after 1 year, the car is worth 24,000. Let's just check what the rate of change would be. So in 1 year, the car has gone down $3,600. Now, if this was linear, the next year would go down by 3,600 again, except it doesn't. Because if I now take 20,400 and go 85% of that, all right, what does that give me? So this is 0.85 times 20,400. And that gives me 17,340. And if you subtract those amounts, you find out that it's 3,060. Those are not the same. So this means not linear. Why is it not linear? The rate of change is not constant. Okay? Let's try this one. Again, let's set up a table. We're going to relate the cost to hours of the service. So if you read this question, it says you call an electrician who charges $75 plus $50 for each hour he works. So this may seem weird, but if he hasn't worked, he's going to charge $75. That's kind of like a house call. Just to show up at your house, it costs $75. If he works 1 hour, he's going to charge you that 75 plus 50. If he works another hour, I'm going to add 50 to that total. Now, if you notice this, for every 1 hour I go up, I should be going up 50. So that means, yes, this is linear. Okay, linear. The rate of change is $50 per hour. Okay, it doesn't ask for this, but if I wanted to write an equation, I would write y equals 50x plus 75. That's the initial amount. This is my rate of change. All right. You have exercise, I think it's 29. Good luck.